Imagine standing on the bank of a vast river. The water flows gently, but endlessly, carrying ripples away toward the far horizon. No matter how far you walk upstream, you can't turn the river back. That's how time works, in our perception and experience, always moving forward from the past through the present toward the future. In physics, this phenomenon is called the arrow of time, a symbolic way to describe the one-way flow that time seems to choose. Look at history from the birth of the universe, 13.8 billion years ago, to this very moment. As you listen to these words, every event follows a sequence that can't be reversed. No one has ever seen a cup of cold coffee heat itself back up, or a block of ice spontaneously refreeze in a warm room without some outside force. The arrow of time is one of the simplest yet most mysterious ideas in science. That's because the fundamental equations of physics, from Newton's classical mechanics to quantum theory, are for the most part time-symmetric. If you flip the direction of time in those equations, they still work. And yet the world we live in tells a different story. On the grand scale, everything in our universe obeys one clear direction. The past and the future are not the same. We can remember what has happened, but never what's yet to come. A wound can heal, but it won't suddenly open again. A candle burns, releasing light and heat, but it never pulls back its smoke and flame to become whole once more. The river metaphor makes it easy to picture, but to understand why time has such an arrow, science often turns to the concept of entropy, a measure of disorder in a system. When ice melts in a glass of water, the neatly arranged molecules in its crystal structure break free into a more chaotic arrangement, and entropy increases. When coffee cools, heat spreads from the coffee into the surrounding air until both reach the same temperature and entropy rises. Natural processes tend to move from order to disorder, and that's why we experience time in one direction. Now imagine a world where entropy decreased instead of increased. Ice would form on its own in a glass of water. Cold coffee would warm itself. People would grow younger instead of older. But that world wouldn't just be strange physically, it would shatter our sense of cause and effect. A broken vase would reassemble before it hit the ground. A wound would vanish before the knife touched skin. Words would be swallowed back into the mouth before they were spoken. History wouldn't be a line moving toward the future, but a film running in reverse. This raises a profound question. If the fundamental laws of physics allow for time to be reversed, why do we only experience it going one way? Is there something built into the fabric of the universe that insists time must flow like this? Or is it simply the result of how the universe began? When scientists look back to the Big Bang, they see a universe starting in a state of remarkable order, very low entropy. From that moment on, entropy has only increased. Perhaps it's this imbalance between an orderly beginning and a chaotic future that gives time its arrow. But the mystery of time isn't just for scientists. For thousands of years, people have wondered about it. Many ancient civilizations imagined time as a circle cyclical following the seasons or the motions of the sun and moon. Yet for each of us personally, time feels like a straight line with a beginning and an end. In every moment, we're carried along by this invisible current, unable to turn back, unable to pause. Each passing second is a part of us slipping into the past, leaving behind only memories and stories. And if somehow for just one instant, the arrow of time could reverse everything we know about life would change. Memories would become glimpses of the future. The past would be something that hasn't happened yet. Science, history, and culture would unravel piece by piece. You'd meet loved ones who had already passed away, only to watch them drift backward out of your life. Growth, love, and grief would all run in reverse, and we'd have to learn an entirely new way to understand meaning itself. Perhaps that's why the arrow of time is more than just a physics concept. It's a powerful metaphor for life. It reminds us that every moment is unique, never to be repeated. The impossibility of going back makes the present precious, giving weight to every choice and every action. Time only moves forward, and that's what makes our story possible. Yet the question still lingers, echoing through theories, equations, and philosophy alike. Why does time choose just one direction? And if there were a way back, would we dare to take it? If the arrow of time is the symbol of an irreversible flow, then entropy is the mysterious compass that points the way. In physics, entropy is a measure of how disordered a system is, or how spread out its energy has become. But that definition feels a bit dry, so let's put it in more familiar terms. Picture this. You walk into your bedroom in the morning. Everything's neat bed, perfectly made, books lined up, sunlight pouring in through the window. Then you go about your day. You change clothes, grab a book, hunt for something in a drawer, and by evening the place looks like a small-scale disaster zone. Every object that moved from its original spot was one small step from order toward chaos. And left alone, it's not going to magically tidy itself. Restoring order will cost you effort energy. That's the heart of entropy. Left to itself, a natural system tends to drift from order toward disorder. Reversing that drift requires an input of energy and work. Physics calls this the second law of thermodynamics, one of the fundamental principles behind everything that happens in the natural world. It doesn't care whether we're talking about a coffee cup, a star, or the entire cosmos. They all obey the same rule. Entropy tends to increase. Here's another example. You're holding an egg. If it slips, shatters, and spills its yolk across the floor, entropy has gone up. You'll never see the egg spontaneously knit itself back together unless you have magic, or a technology that doesn't exist yet. Not because physics strictly forbids it, but because the odds of every atom arranging itself perfectly again are so staggeringly small that for all practical purposes, it's impossible. Strangely enough, on the microscopic level, things work differently. Fundamental particles like electrons and photons don't seem to care about the difference between past and future. The equations describing their motion work just as well if you flip time backwards. In that sense, the universe's basic rules treat past and future equally. But when you gather billions upon billions of particles into a large-scale system like a bedroom, a coffee cup, or a planet, entropy emerges as an overwhelming statistical trend. That's the paradox. The deep laws of physics are time-symmetric, yet the world we experience has a clear direction. Back to our messy room. The reason it doesn't clean itself is simple. There's an astronomically low chance that random motion will put every object exactly back where it started. Disorder is easy. It can happen from a few careless actions or from doing nothing at all. Order requires precise, directed effort. The same is true for a block of ice left in the sun. It melts as heat increases the chaotic motion of water molecules. But those molecules won't spontaneously lock themselves back into the crystal structure of ice without outside energy. And this isn't just true for familiar things, it's true for the universe. At the Big Bang, the cosmos began in a state of astonishingly low entropy. Since then, entropy has steadily risen as stars were born and died, galaxies swirled and scattered. Look at the universe's history, and it's like watching a perfectly arranged room gradually slip into cosmic clutter. The arrow of time might simply be the legacy of a universe that began too orderly. This idea reaches far beyond explaining why coffee cools or ice melts. Entropy is why we can tell the past from the future. The past is the place where entropy was lower than it is now. The future is where it will be higher. Even memory depends on this. Your brain's act of storing an experience involves building structure out of a less ordered state, and that process only happens alongside an overall increase in entropy. If time truly ran backwards, memory itself would reverse, flipping our entire sense of cause and effect. Here's the twist: since the fundamental laws are symmetric, there's nothing in principle stopping processes from running in reverse. It's all about probability. Over absurdly long timescales, tiny random fluctuations could make a small part of a system become more ordered again, like a single gas molecule drifting back to its original corner of the room. But on large scales, these events are so rare, they're essentially invisible, and yet that sliver of possibility sparks the imagination. If we could manipulate probabilities or control the microscopic motion of every particle, could we bend the arrow of time? This is where physics begins to fade into philosophy. If the core laws allow time to run backwards, is our one-way experience of it destiny, or just a cosmic accident born from the universe's starting conditions? Could there be another universe where entropy runs in reverse, whose inhabitants see us as the ones living backwards? And is there some middle ground where two arrows of time meet? These aren't just abstract puzzles. They remind us that what we take as absolute might only be part of a larger picture. From some vantage point beyond the boundaries of our universe, the idea of a direction to time might be meaningless. In that light, time might not be a single river at all, but a tangled network, some streams flowing forward, some backward, all weaving together. So if physics allows symmetry, could the arrow of time be an illusion born from our way of looking at things? And if we could step outside that illusion, would we dare imagine the universe not as a one-way journey toward endless expansion, but as a piece of music with an opening, a crescendo, and a finale, only to start again from the beginning? In some cosmological models, this isn't just poetic imagery. It's a real possibility the universe could expand, then one day stop and begin to contract, rewinding its entire story. This idea is known as the Big Crunch. In this scenario, gravity would eventually overpower the force driving expansion, pulling everything back together, compressing all of space-time matter and energy into an incredibly hot, dense state, perhaps much like the moment before the Big Bang. Picture the universe as a giant balloon being inflated. Right now, we're in the expansion phase, galaxies drifting apart, the distances between stars growing ever wider. But if one day the inflation stopped and reversed, the balloon would slowly begin to deflate. In cosmic terms, galaxies would start moving closer, vast stretches of space would shrink, and eventually the entire universe would collapse in on itself. Some models go even further, suggesting the Big Crunch might not be the end at all, but a bridge to a new cycle. Like the breath of a colossal living being, the cosmos could expand and contract forever. After each collapse, a new Big Bang might ignite another era of expansion. If true, this cycle could have played out countless times before we appeared, and may continue long after we're gone. Now picture a far-off future when the contraction begins. In a reversing universe, the light from distant stars would gradually shift to blue instead of red as wavelengths compress rather than stretch. Galaxies would inch closer, cosmic collisions would become more common, and the night sky would blaze with spectacular mergers and explosions. But as the process continued, space and time themselves would grow denser and hotter until everything collapsed into a single point. What's both fascinating and eerie about the Big Crunch is how it rewrites our cosmic fate. Instead of drifting toward an infinite future of cold darkness and isolation, this vision ends with everything reunited, distances erased, the universe returning to its origin. From a philosophical view, it almost feels like a kind of homecoming, even if that home is a chaotic, uninhabitable state. If you imagined living in a contracting universe, everyday experience would slowly change. Time itself, or at least our sense of it, might flow differently as the fabric of space-time was squeezed. Some theories even suggest the arrow of time could reverse. In that case, we might witness reality playing backwards, stars growing younger, planets retracing their orbits, people growing smaller and younger until they vanish into the moment before they were born. This remains speculation. There's no solid evidence, but it's an unsettling thought. One deep philosophical question here is about meaning. If the universe is just part of an endless loop, have we lived this exact life before? Has Earth's history, humanity's history, unfolded identically, billions of times? Or does each cycle bring something new? And if everything eventually repeats, does progress mean anything at all? Or are we just acting out a script written by the cosmos itself? These questions can make you feel small, but they can also bring a strange sense of connection. In the Big Crunch vision, nothing is truly lost. Everything simply dissolves, only to reunite again. Every planet, every star, every atom that was once part of you would return to a primal state and might one day help build a new world. It's an ending that is both destructive and creative, closing one chapter while opening another. The trouble is, if this really happens, no civilization, however advanced, could escape it. No machine, no power source, no star could resist the collapse of space itself. Unlike local threats such as asteroids or supernovae, the Big Crunch would be a cosmic-scale event inescapable by definition. And here's the unsettling twist. What if it's already happening? We might already be in the very early stages of contraction, but because cosmic timescales are so vast, the change could be imperceptible over a human lifetime. Or maybe by the time the signs become obvious, it will be far too late for any civilization to react. So, what would happen to us if it began right now? Imagine we could build a truly extraordinary machine. Not a time machine that carries a person into the future or past, but a cosmic clock, a device that could reverse the entire flow of time within its domain. You place this clock inside a sealed pocket of space containing a miniature system of planets, artificial stars, and even simulated life forms. When the clock is activated, everything inside begins to run backwards. Atoms trace their paths in reverse photons, bend back toward their original sources, and every physical process unfolds like a film being rewound. But here's the real puzzle. The question isn't just whether matter and energy can be made to run in reverse, it's whether the conscious minds of the creatures inside would also flow backwards with time, or whether they would still experience it moving in the familiar forward direction. In theory, quantum mechanics offers an intriguing foundation for this thought experiment. The Schrödinger equation, the beating heart of quantum theory, describes how the state of a quantum system changes with time. Curiously, if you flip the sign of time in this equation, it still works. In other words, pure quantum processes are perfectly reversible. An electron orbiting an atom could run backward along its path, but only if every single factor affecting it were also reversed. This hints at a fascinating possibility. If we could control every particle and every interaction with absolute precision, we could make an entire system roll back to a previous state. The catch is that we never observe a quantum system in perfect isolation. Every measurement, every interaction with the outside environment causes the loss of quantum information, a process known as decoherence. Decoherence is what breaks perfect reversibility when we scale up from the microscopic world to the macroscopic one. In our imagined cosmic clock, truly reversing time would require reversing everything in the system, the measuring devices, the environment, and even the observers themselves. And this is where things get truly strange. If we conscious beings were reversed along with the system, all our memories, emotions, and perceptions would also be reversed. From a first-person perspective, we wouldn't feel like we were moving backwards through time at all. The memories of what was once the future would vanish, replaced by memories of a past that now exists in the reversed timeline. Inside such a world, you'd still believe time was moving forward, even though from the outside, everything was running in reverse. This leads to a curious paradox. If consciousness always experiences time in the direction where entropy increases, then in a reversed universe, our perception of forward would flip accordingly, and no one inside could ever notice the change. The only way to know would be for an outside observer to compare the two timelines. This thought experiment shakes the very foundations of our intuitive sense of time as a flowing objective river. Perhaps time doesn't flow at all. Perhaps it's simply a sequence of physical states, and our minds create the sensation of moving between them. If that's the case, then reversing time would just mean changing the order in which we experience those states. Memories, causes, and effects would all be rewritten, yet the person inside wouldn't suspect a thing. But another question emerges: what if we reversed matter and energy without reversing the information patterns in the brain? In that case, consciousness would remain intact while the outside world rewound like a backwards movie. Raindrops would leap from the ground into the sky, flames would collapse into a tiny spark, and spoken words would be sucked back into the speaker's mouth. It would be an utterly disorienting, perhaps even psychologically devastating experience, as every familiar rule of cause and effect unraveled before your eyes. From the perspective of quantum mechanics, such an experiment is still far beyond our technological reach. But imagining it forces us to confront deep questions about the nature of time and consciousness. Is awareness inherently tied to the arrow of entropy, able to exist only in one time direction? Or is it something independent, able to flow either way, depending on the physical context? And if it can exist in both directions, would it feel fundamentally different, or would it preserve the same unbroken sense of self? All of this suggests a deeper truth. To truly understand time physics alone might not be enough. We may also need to look to neuroscience, cognitive science, and philosophy, because perhaps the answer to whether time can be reversed lies not only in the equations, but in the way our brains and minds construct the reality we live in. So to begin answering that question, let's take a closer look at time in the quantum world. In our everyday lives, we experience time as a steady, orderly flow, always moving in a single, unmistakable direction. Morning follows night, the sun rises, then sets, and events unfold in an unbroken chain that can't be reversed. This is time on the macroscopic scale, the world we see and live in. But when we step into the microscopic realm of quantum mechanics, that familiar picture begins to crumble. Here, the usual rules of time seem to dissolve, giving way to possibilities that would be impossible in the larger world. One of the clearest differences between macro time and micro time lies in symmetry. In our everyday world, entropy increases, giving time a single arrow pointing forward. But at the quantum level, the basic equations that describe how particles move, like Schrödinger's equation or even Newton's classical laws, don't actually care which way time flows. Flip the sign of time in those equations, and they still work. In other words, an electron or a photon couldn't care less whether you call it past or future. It plays by timeless rules. Quantum mechanics also brings us one of its most famous principles, Heisenberg's uncertainty principle. It tells us you can't know both the exact position and velocity or momentum of a particle at the same time. The more precisely you pin down one, the fuzzier the other becomes. This isn't about the limits of technology, it's a fundamental feature of reality. As a result, on the quantum scale, particles don't sit like tiny marbles in space and time. They exist as shimmering clouds of probability, constantly fluctuating. Time here isn't a smooth river, but a tangled web of possibilities where past and future can overlap in strange superpositions. Another wrinkle in our idea of time comes from quantum fluctuations. Even in a perfect vacuum, which we think of as empty pairs of particles, and antiparticles are constantly appearing and disappearing, borrowing tiny amounts of energy for fleeting moments in apparent violation of energy conservation, but still obeying the uncertainty principle. From the perspective of the big classical universe, these fluctuations are like whispers barely noticeable. But in the microworld, they reveal that time can tremble in ways that defy intuition, and under special conditions, might even reverse itself. Picture a simple quantum system, say a hydrogen atom. Its electron doesn't orbit the nucleus like a planet around the sun. Instead, it exists in a haze of probabilities, being here or there until you measure it. Between measurements, quantum equations allow that electron to move both forward and backward in time without breaking any laws. Mathematically, time here is almost neutral. Only when decoherence happens, when the system interacts with its environment, does the arrow of time snap into place. This leads to a fascinating possibility. If we could completely isolate a quantum system from the outside world, we could, in principle, reverse time for it. The spin-echo experiment in nuclear physics demonstrates this. In it, the spins of atomic nuclei are scrambled, then hit with a special magnetic pulse that causes them to realign, essentially rewinding their state. It's fleeting, and it only works on tiny systems, but it shows that microscopic time reversal isn't just science fiction. The leap from the microscopic world to our macroscopic reality, however, is enormous. As soon as particle numbers increase and they interact with their surroundings, decoherence happens almost instantly, destroying any chance of reversal. A single atom might run backward for a billionth of a second, but a drop of water, a rock, or a human being can't. There are simply too many particles, too many interactions, and every collision with a photon or a gas molecule hammers the arrow of time firmly in place. And so we arrive at a philosophical puzzle. If time is reversible at the deepest level, why do we live in a world where it only runs one way? Perhaps the answer lies in the statistical nature of entropy, or in the way consciousness and memory work. Maybe in the micro world, past and future are twins, but in the macro world, entropy forces us to choose just one to walk alongside. Thinking about the contrast between micro time and macro time leads to a curious realization. Everything we experience, our memories, our histories, our hopes, is the product of a one-way time arrow at the large scale. But if you could shrink yourself down to the size of a particle, your sense of time might dissolve completely, leaving you in a world where every moment exists at once, and before and after are just a matter of perspective. At the human scale, though, that's something we can only dream of. In science fiction, the image is iconic: a spaceship plunging into a glowing tunnel between the stars, only to emerge somewhere else in the universe, or perhaps in another moment in history. But the idea of such tunnels, better known as wormholes, isn't purely the stuff of imagination. It comes straight from the equations of Einstein's general relativity, which describe how space and time can bend, twist, and connect in astonishing ways. A wormhole, in theory, is a shortcut through space-time, linking two distant locations, or even two different points in time. Picture space-time as a flat sheet. Place 2 points on opposite ends of the sheet, and the distance between them is long. But fold the sheet so that the points touch, and suddenly you only need a short path to move from one to the other. That shortcut is what a wormhole would be: a bridge tunneling through the fabric of the universe. The theoretical model has two mouths connected by a throat, forming a curved passageway through space and time. The challenge is keeping one open long enough to travel through. For that, you'd need a strange kind of matter called negative energy matter, something we're not sure exists naturally. In physics, negative energy isn't simply less energy in the usual sense. It's a state with an energy density lower than the vacuum itself. Some quantum effects, like the Casimir effect, hint that negative energy can exist on a microscopic scale. But to hold a wormhole wide enough for a human or spaceship to pass through, the amount required would be colossal, far beyond anything our technology can currently produce. If, however, a stable wormhole could be created, it might double as a time machine. Keep one mouth still while moving the other near the speed of light, or place it in a strong gravitational field, and time dilation will desynchronize them. Step through, and you wouldn't just travel across space. You'd jump to another moment in time. That opens the door to traveling into the past, an intoxicating idea, but one riddled with famous paradoxes. One of the most famous is the grandfather paradox. Imagine you go back in time and prevent your grandfather from meeting your grandmother. Your parent is never born, meaning you're never born, meaning you never made the trip back in the first place. But if you never went back, who stopped them from meeting? This loop of logic leads many to suspect that traveling to the past might be impossible. Modern physics offers a few possible workarounds. One is the Novikov self-consistency principle, which says that events in time are fixed and consistent. No matter what you do in the past, the end result will always lead to the present, you know. In that case, if you tried to stop your grandparents from meeting, a chain of events would inevitably foil your attempt, ensuring history unfolds exactly as it did. Another approach comes from the multiverse hypothesis. In this view, changing the past doesn't rewrite your original timeline. It spawns a new branch, a parallel universe where events play out differently. In your original universe, you still exist and made the trip. In the new one, you might never be born. This sidesteps the logical paradox but raises new questions. If every action creates a new universe, are there infinite universes? And does changing history really mean anything if you're only creating a new one rather than altering the old? There's also a more philosophical twist. If backward time travel is possible, it might force us to accept that free will, as we understand it, is an illusion. If events are pre-written to avoid paradoxes, then every choice, including the choice to travel through time, was inevitable. On the other hand, the multiverse model offers a freer view where each decision creates its own reality. But the price is the fragmentation of a single shared history into countless parallel possibilities. From any angle, wormholes and time travel sit on the edge of science and imagination. They're grounded in real mathematics, yet rich with the imagery and wonder that have fueled human stories for centuries, from ancient myths of portals to other worlds to sci-fi adventures across the ages. And because they push against the ultimate limits of existence, space, and time themselves, wormholes become a mirror for our deepest questions about reality. Can the past be changed, or is it a solid, unshifting block? Is the present just a thin slice of an immense space-time loaf where every moment, past, present, and future, already exists forever? And if we could step through a door to another time, would we truly be leaving the present, or simply moving to another part of a cosmic structure that's already there? Perhaps the greatest doorway wormholes open is the one into philosophy. Imagine waking up one morning to find your memory no longer works the way it used to. Instead of recalling yesterday, your mind begins remembering tomorrow, while the events of today slowly fade away. Every moment you live carries memories of the future and only a hazy impression of the past. This isn't foresight or intuition. It's a genuine reverse memory flow running in the opposite direction of the time we know. To picture what this feels like, imagine reading a thick novel, but instead of starting from the first page and moving forward, you begin at the very last page and work your way backwards. Each new page you turn isn't an advance in the story, it's a step back, revealing why the events on the later pages happened. You always know the ending, but the causes remain unclear, only surfacing as you move in reverse. In life, that would mean knowing the outcome of your actions before they happen, yet not understanding the reasons until they unfold, at least from the perspective of everyone else. Such a life would completely flip our idea of cause and effect. Normally, we act based on past experience and expectations of the future, but in a reverse memory world, you'd make choices based on remembered consequences, while the causes of those consequences would only show up later. This wouldn't just be confusing. It might shatter your very sense of self, the continuous thread that tells you who you are. Picture this: you clearly remember that tomorrow you'll meet a stranger, and that meeting will change your life. In a normal world, you'd wait, prepare, anticipate. But in a reversed memory world, you already know the meeting happened, you feel its impact, but when it finally occurs in physical time, you're unprepared, unaware. Every action becomes a reflex to fill in the blanks your future memories have left behind. This raises a profound question in such a world: would free will survive? If you already know the result of every choice, can you change it? Or will everything play out exactly as it's already remembered, making change impossible? This is a different kind of time paradox, not about traveling physically to the past, but about reversing the inner flow of memory. Philosophers might argue that in such a world, free will would be warped or erased entirely. If memory is the basis for decisions, and that memory comes from the future, then every action is simply the execution of a pre-written script. Others might counter future memories could be only a reference frame, leaving room for you to react differently and create a new chain of events. But if you did that, your original memories would no longer match reality, and your sense of identity could fracture. Psychologically, reverse memory would disrupt the deepest layers of our cognition. We build the story of our lives from past memories, a narrative that helps us know who we are, who we were, and who we might become. If that timeline were flipped, your present self would always be the result of a future self that hasn't yet happened. It could feel alien, like you're living someone else's life without truly understanding them. Memory is also the foundation of human connection and trust. If two people's memories run in opposite directions, or if one's are reversed while the others aren't, communication would break down. One person could talk about the outcome of an event before it happens, while the other could only speak of its cause after it's over. Shared experience would vanish, as each person would live in an entirely different sequence of cause and effect. Now imagine a world where everyone shared reversed memory. Their society would evolve in an entirely different way. History would be recorded from results backward, to causes and plans for the future would be built on memories that already exist instead of predictions. Politics, science, art, all would take on a strange new character, where every project begins with the completed masterpiece and works backward to uncover the path. But there's a danger. If everyone already remembers the outcome of collective actions, the drive to act at all could fade. If you know a project will fail, would you still start it? And if you know it will succeed, would you dare change anything, afraid to break the certainty of your memory? In either case, society could stagnate, trapped in the loop of a preordained script. Reverse memory also stirs deep metaphysical questions about the nature of time and consciousness. Is consciousness simply the flow of memory from past to future? If so, reversing memory would mean reversing the direction of time in the mind, regardless of the physical world outside. And if memory can run backward, could there exist a kind of multi-directional awareness where past and future coexist in a single expanded present? In the end, even as a thought experiment, reverse memory forces us to rethink the meaning of life itself. We usually search for purpose in the future, guided by what we've experienced in the past. But if memory comes from the future, then purpose becomes something already set, and the past merely a chain of causes waiting to be discovered. In that world, the question is no longer, where am I going? But how did I get here? Would free will still exist at all? Free will, the idea that each of us can choose our own actions, has long been one of philosophy's most hotly debated topics. Even when time moves forward, the clash between free will and determinism is already tangled enough. But place that debate in a world where time runs backward, or where memories flow from the future into the past, and the arguments we're used to suddenly feel fragile. Let's start with a simple picture. In forward-moving time, we see the future as an open landscape of unknowns full of possibilities. We believe our actions in the present help shape that future. It's the perfect soil for free will to grow because we feel like direct agents of change. But if time were reversed, or if our memories came from the future, that future wouldn't be an unknown anymore. It would already be. They're remembered, felt perhaps down to the smallest detail. Here's the problem. If every event has already happened in the future, do we still have any real choice? A strict determinist would say no, we're simply acting out a script that's already written, like actors stepping onto a stage, speaking lines and following stage directions. Even when we think we're improvising, that too could just be part of the script written to make us believe we're free. But not everyone accepts that so easily. Some philosophers and physicists argue that even if the future exists in some form, it isn't necessarily fixed. Perhaps memories from the future reflect only the most probable outcome, not the only one. If that's the case, then our actions in the present could still alter the course of events leading to a different future. And those original future memories would then belong to a branch of time we left behind. On the other hand, if we accept that every event is perfectly consistent and unchangeable, like the Novikov self-consistency principle in physics suggests, then free will shrinks to almost nothing. Every choice, every action, every decision we make becomes an inevitable step on a path already laid out. That's when personal responsibility becomes a tricky question. If I couldn't have acted differently, can I really be blamed for causing harm? And if something good happens, can I truly take credit? Or was it simply inevitable? Some thinkers propose redefining free will altogether, not as the ability to do otherwise, but as the ability to act in line with your own nature and desires, whether those were inevitable or not. In a reverse time world, this would mean that even if you're following a fixed script, you're still free if that script reflects who you are. But this definition makes free will a subjective experience rather than an objective reality, more of a comfort than a truth. Reverse time also changes the way we assign meaning to choices. In forward time, a choice matters because it opens or closes doors to the future. In reverse time, a choice matters because it's a necessary link in maintaining the consistency of future memories. choices become less about creating something new and more about preserving what's already been set an effort to keep reality from breaking. Psychologically, this could drain our motivation and sense of control. If you believe every outcome has already happened, you might slip into passivity, seeing yourself more as a spectator than a participant. But it could also bring a strange peace. If everything is predetermined, there's no need to fear making the wrong decision. Every choice is right in the sense that it fits perfectly into the structure of time. That peace, though, is double-edged. It can free us from anxiety, but it can also lead to apathy. A world where everything is already set is a hard place to nurture creativity, innovation, or sacrifice, since the outcome doesn't depend on anyone's effort. Moral questions get thorny too. If a criminal couldn't have acted differently, should we punish them? If a hero couldn't help but act bravely, should we praise them? One way to salvage responsibility is to see it as part of the deterministic script itself. In other words, holding people accountable or rewarding them is just another link in the unchangeable chain of events. Responsibility doesn't vanish, it simply changes its nature. It's no longer the product of free choice, but a built-in feature of the story. Dig deeper, and reverse time challenges free will in an even stranger way. The very idea of the present moment starts to lose its familiar meaning. In forward time, the present is where the fixed past meets the open future. In reverse time, the present might just be another step on the journey toward a past that hasn't happened yet, a strange state where now is no longer the center of decision-making, but just a point along a pre-drawn path. And yet, even in this picture, some philosophers find a new value in the present. If you know the future, but not the past, the present becomes your only chance to uncover the causes that led to the outcome you've already seen. Every action becomes a clue, a puzzle piece, helping you understand your own story. You can't change the ending, but you can savor the process of finding out how it all came to be. Perhaps this is where free will, or at least the feeling of it, still survives. Not as the power to shape the future, but as the power to shape how we experience and interpret the chain of events. One person might meet their future memories with curiosity, another with fear, another with indifference. These reactions don't alter the events, but they do alter the lived experience, and for many that's enough to call it freedom. And maybe in the end, that's the reminder. The value of the present moment is still worth holding on to. Imagine a world where time doesn't march forward as we know it, but drifts silently, in reverse, pulling with it every biological process woven into the fabric of life. In this world, aging, one of nature's most unshakable laws, runs backwards. Instead of hair gradually turning grey skin, gathering wrinkles and bodies growing frail, we'd witness the opposite, wrinkles fading away. Silver hair reclaiming its original color wounds, not only healing but vanishing as if they never existed, and organs growing healthier with each passing day. Here life would begin in old age, carrying the marks of decades gone by, and steadily rewind until one becomes a newborn. From a biological standpoint, this flips the entire concept of development on its head. Rather than learning, gaining experience, and building skills over time, we would slowly lose them. A person might know how to read, calculate, or play an instrument in their middle years of reverse time, only to have each of those abilities fade as neural connections shrink and the body returns to its most primitive state. Evolution itself would be rewritten. In forward time, evolution is driven by reproduction and natural selection. Those best adapted pass on their genes. In reverse time, reproduction takes on a strange twist. A child would actually be the final stage of a life. To give birth would mean completing the rejuvenation cycle and disappearing from existence entirely. That raises a profound question: would the next generation truly be new, or merely shrunken, reset versions of individuals who had already lived? The ripple effects wouldn't stop at biology, they'd reach deep into the collective memory of society. History would no longer be a story moving from past to present, but a chain of events beginning with the outcome and slowly revealing the cause. History books would open with the current state of the world, then work backwards step by step, explaining how it came to be. Learning from the past would feel strange because from the perspective of someone living in reversed time, the past hasn't happened yet. Science too would be turned inside out. In our world, a scientist observes a phenomenon, forms a hypothesis, tests it, and draws conclusions. In reverse time, they would start with a conclusion already in hand and work backwards to uncover what experiment could have led to it. This could spark unexpected breakthroughs, since results are known in advance, but it might also choke creativity as the goal is already fixed, and any deviation would break the chain of events. On a personal level, relationships would be transformed. Friendships and romances, instead of starting with unfamiliarity and deepening over time, would unravel in reverse. Two people who are young lovers in the reversed flow would gradually drift apart until in their old age they are complete strangers. This would reshape how people see commitment and what forever means, because in this world, forever would eventually end in total forgetting. Even morality and responsibility would shift. In forward time, we're accountable for our actions because they affect the future. In reverse time, your actions would affect the past, a past that from your perspective hasn't happened yet, because would follow effect consequences would come first, and society might build laws and ethics around preserving the consistency of time itself, rather than preventing harm to an unknown future. This leads to the big question, could life in reverse time sustain its complexity and diversity at all? Some speculative biologists argue that if every biological process runs backwards, life might evolve towards simplicity, shrinking in variety and structure rather than expanding. This would be the opposite of what we see in forward time, where biological entropy tends to increase. Culture, too, would warp in fascinating ways. Art, music, literature, all shaped by human perception of time, would flip. A symphony would be composed from its finale back to its opening notes. A novel would be written from its last chapter to its first. Audiences would find this perfectly natural. Creative works wouldn't aim for a climax at the end, but for a kind of release at the beginning, because in reverse time, that is the true ending. And perhaps the most profound shift would be in how people define the meaning of life. In forward time, meaning often lies in the end goal, a legacy, an achievement, a lasting change for the better. In reverse time, the ultimate destination is infancy, a blank starting point. This might push people to value the experience of living and maintaining the thread of continuity, rather than chasing progress or transformation. And if all this weren't strange enough, imagine only part of the universe running in reverse, while the rest flows forward. The boundary between the two would be a chaos zone, where cause and effect might collide, tangle, or vanish entirely. Beings on either side could never truly understand each other, because even before and after would mean different things. It would be a place where science, philosophy, and even religion might join forces to seek answers, or accept that some questions will never be solved. But what if only part of the universe reversed? Imagine if the universe didn't have just one single arrow of time, but was instead part of a vast network where each cosmic branch could carry its own unique flow of time. In one branch, time moves from past to future as we know it. In another, it flows backwards, pulling everything from the future into the past. And then there are stranger realms, where time doesn't pick a side at all, oscillating back and forth, like cosmic tides, rising and falling without a fixed direction. This idea leads us to the concept of the multiverse, a vast collection of parallel realities, each with its own laws, where the arrow of time is just one variable among many. In this grand multiversal tapestry, our universe is nothing more than a single drop in an infinite ocean. The forward-pointing arrow of time we take for granted might be a rare configuration, not the cosmic standard. Somewhere out there, a universe could operate under the exact same physical laws as ours, except time runs in reverse. Another could make time crawl so slowly that a single second for us would stretch across millions of their years, or pass so quickly that billions of their years would vanish in the blink of our eye. And this sparks a fascinating question. Could universes with different arrows of time ever interact? In theory, if there were a bridge, a wormhole, a quantum bubble, perhaps a special kind of Einstein-Rosen bridge, then communication, or even travel between such realms could be possible. But the clash of time directions would create strange, unpredictable effects. Picture a traveler from a forward-time universe stepping into one where time runs backward. Suddenly, cause and effect flip. An action they take might create its own cause instead of its result, or erase the very reason it was taken in the first place. Even conversation would be bizarre. One side expects an answer after a question, while the other receives the question only after they've sent the answer. From a physics standpoint, some theories suggest that if two universes with opposite arrows of time touched at a boundary, that contact could form a temporal turbulence zone, a place where entropy neither rises nor falls, but fluctuates unpredictably. In such a region, the usual laws of thermodynamics might break down entirely, allowing impossible phenomena, water freezing and melting spontaneously, or life emerging from perfect chaos to occur naturally. From a philosophical angle, a multiverse with multiple time arrows challenges the idea of an absolute reality. If in another universe our future is their past, then time is not a universal river, but a local experience. This shakes the notion of objective truth, forcing us to admit that any description of time and causality might only hold meaning within the bounds of a single universe. Some scientists even speculate about synchronization windows, rare moments when universes with different time arrows briefly align in phase. During these windows, information or matter could pass between them without creating paradoxes. If humanity could detect and harness these moments, we might gain access to infinite knowledge, technologies, scientific breakthroughs, even histories that unfolded under entirely different flows of time. Still moving matter or people between such universes would be dangerous. Someone, from a forward time reality entering a reverse time one, would have to adapt to a completely alien way of experiencing existence, where memories are built from the future and fade as they approach the past. This could trigger severe psychological crises, even fracture consciousness itself. Another intriguing consequence is the possibility of information loops. Imagine sending a message from a forward time universe to a reverse time one. It would arrive in their past, potentially changing their future, which is your past. If that altered information then returns to you through another exchange, it could become causeless, existing without a true point of origin. A fresh kind of time paradox, different from the grandfather paradox, but just as maddening for theoretical physicists. Some take this further, suggesting universes with opposite time arrows could act as each other's memory banks. Information lost in one universe through rising entropy could still exist in another, where entropy decreases. If we could access and synchronize these data, restoring the past or predicting the future might become possible, at least in theory. Such a feat would transform our understanding of history, science, and the very nature of memory. Of course, all of this remains in the realm of speculation. We have no experimental evidence for the multiverse, let alone a way to check its arrows of time. But intriguingly, nothing in the fundamental equations of physics forbids multiple different arrows of time existing across parallel realities. If a multi-time universe truly exists, the next big question is, could we choose our own arrow? That's not just a technical challenge, it's a question of identity and meaning. Would we live where time flows forward, where memories weave a story from past to future, or choose a reverse flow, telling our story from the ending back to the beginning? In the end, no matter the answer, the very idea of a multi-time universe reframes our original question, why does time have a direction at all? And is that direction truly unique? Because if the arrow of time is just one of countless possibilities, then what we call natural may only be the thinnest slice of a far greater reality. And so we return to where we began. Time has always been the silent backdrop to every story in the universe. It never speaks, never tries to claim the spotlight. Yet it is the ultimate director and scriptwriter, shaping the rhythm and structure of everything that happens. In our journey so far, we've traveled from the basics of physics, the arrow of time and entropy, through grand hypotheses like the Big Crunch and the multiverse, and into deep philosophical reflections on consciousness, free will, and the meaning of life. Each chapter hasn't just offered a new perspective, it's revealed how time in all its forms threads everything together. If we imagine existence as a vast tapestry, time is the interwoven strands binding every moment, every particle, every thought. Without it, the whole fabric would unravel into scattered fragments, no story, no cause, no effect. Time allows things to unfold in sequence, or at least in a sequence we can comprehend. It is the stage for every movement, the rhythm for every song of existence. Now picture a universe where time flows backward. Everything familiar becomes strange. Cause might swap places with effect. Memories could fade in reverse, and life could move toward its beginning instead of its end. Even the very idea of the present is challenged, if it's not the bridge between past and future, but a pause between two opposing streams. How would we define it? This isn't just a question of physics. It's a question about the essence of human experience. What's fascinating is that whether time flows forward or backward, its mere existence, no matter the direction, is what makes our stories possible. In a forward-flowing timeline, we tell stories from cause to effect, from beginning to end. In reverse, we tell them from end to beginning. Both can be rich with emotion and meaning. The only difference is where we start and where we stop. But if we ask, what would change if time reversed, we also have to ask, what wouldn't? Perhaps it's our need to seek meaning, our desire to understand our place in the grand design, our instinct to connect scattered moments into a coherent whole. Time might flow either way, yet conscious beings, human or otherwise, would still try to piece together their experiences into some kind of ordered sequence. Because a story isn't just something we tell, it's how we exist. From this perspective, time isn't merely a physical quantity to measure, it's the greatest storyteller of all. It knows how to build tension, how to hide certain details, only to reveal them later, how to make us hold our breath, rejoice, or grieve. And like any great story, its magic isn't just in the ending, it's in how it's told. Thinking about reverse time, multiple universes, or different temporal directions is in a way an exercise in appreciating the flow we live in now. When we imagine a world where memories dissolve instead of accumulate, where people drift apart instead of growing closer, where every action is taken to complete a past that hasn't yet happened, we begin to see how remarkable it is to live in a forward-moving stream. We can remember, learn, build, and leave our mark on the future. Every passing moment becomes a brick in the road ahead, and we are the ones choosing where it leads. There's a quiet paradox here. The deeper we think about time, the easier it is to get lost in strange possibilities and far-off scenarios. And yet, those very thoughts pull us back to the present, reminding us that this moment, fleeting as it is the only thing we truly hold. The past has become memory, the future remains a mystery, and the present is where they meet. If time is the storyteller, then the present is the sentence being written right now. And perhaps somewhere out there in a parallel universe with time flowing in reverse, another version of us is also sitting here. Only their memories begin in what we call the future, and their questions reach toward the past. Maybe they're wondering the opposite. If time could flow forward, what would happen? Our question and theirs, though opposite in form, meet at the same point, the desire to understand the nature of time and our place within it. In the end, no matter which way time flows, the essence of being alive is the same. We are curious. We want to explore. We long to tell and hear stories. Time, the greatest narrator, gives us the stage, but the plot, the twists, and the meaning are ours to create. One day, science may unlock a way to travel between different directions of time, or even to other universes. But even then, we would carry the same instinct to find the storyline, to seek meaning, and to share it. So whether you live in a forward-backward or oscillating timeline, perhaps what matters most isn't the direction, it's how you fill the pages as they're being written. Because in the end, time is not just the frame that holds the story, it is the story. And in that story, no matter how vast or complex the universe becomes, each of us is a unique character, weaving a single thread into the endless tapestry of existence. And maybe, somewhere out there, another version of us is living the opposite way around. And they're wondering too, what if time could flow forward?